Sri Lanka Institute of Information Technology. Programming Language and Design Concepts. Let's look at what is FORTRAN. In long term, FORTRAN stands for IBM Mathematical Formula Translation System, but abbreviated to Formula Translation. John W. Backus and his team began the design and programming of FORTRAN in early 1955 and released the system in 1957 at the Western Joint Computer Conference in Los Angeles. FORTRAN based towards efficiency and designed towards running on specific hardware. It comes under procedural paradigm. FORTRAN is a first-generation language which is derived from IBM Mathematical Formula Translating System, and it became most acceptable compiled programming language. FORTRAN is a general-purpose language, and it is especially suited to numeric computation and scientific computing. Major contribution of FORTRAN is the use of algebraic notation. FORTRAN has been revised several times. As a result of that, there are several versions of FORTRAN. Some of the versions are FORTRAN 1, FORTRAN 2, FORTRAN 3, FORTRAN 4, and so on. FORTRAN 1 used for specified purposes, and then FORTRAN 2 is implemented for IBM 704. FORTRAN 4 is still an important dialect. The most important thing is FORTRAN language has survived during so many decades. And nowadays also we using FORTRAN language. FORTRAN 77 is the successive version that has been added to support for processing of character-based data. FORTRAN 90 is support for array programming, modular programming, object-based programming and object-based generic programming. FORTRAN program is a collection of subprogram and definitions. Subprograms may be a function that returns values, a subroutine that doesn't return a value, and must not be the main program. The initial release of FORTRAN for the IBM 704 contained 32 statements, including dimensions and equivalence statements. Three-way architecture of statements for checking exceptions. Now we will look at the features of the FORTRAN language. FORTRAN is a machine-oriented language. It contains primitive data structures, and we could not find hierarchical data organization. FORTRAN has weak type checking. No recursion 1 Arkansas for subprograms. FORTRAN does not have any keywords and exception handling. FORTRAN used mixed mode operations. Now let's see some program structures of FORTRAN language. FORTRAN has one main routine and 0 or more subroutines. Scope of these two main and subroutine are completely disjoint. It means they cannot be separately compiled. As you can see, this language consists of two main constructs: declarative construct and imperative construct. Declarative have the ability to allocate memory, bind a name and initialize. Imperative have the ability to computation, flow control and input or output. Now let's look at FORTRAN's syntax. FORTRAN is a machine-dependent language. It contains fixed format for punch cards. FORTRAN's syntax is predefined function for sets of columns. FORTRAN used continuation when card not large enough. Now let's look at the FORTRAN formats. The FMT SUBOP accepts a FORTRAN format specification. This is useful when data are not separated by delimiters, so that the standard unformatted read command is inapplicable. A FORTRAN format specification is a list of format elements describing the variable format. Variable formats are real number in either decimal or exponential form, the width of each variable, and the number of decimal places. 3 variable formats are supported: RE, F, and G. The most common variable format is the F format for real numbers in decimal form. The syntax for this format is FWD, where W is the width of the variable and D is the number of decimal places to the right of the decimal point. For example, F4.0 would read a 4-digit number with no implied decimal places. When there are no implied decimal places, as in the case of F4.0, the format description can be simplified to F4 alone. If, however, the data are written with an implied decimal, the user can specify a decimal point to the left of the last D digits. Any decimal actually coded in the data overrides the format specification. The E format allows the user to enter data stored in scientific notation. The syntax of the E format is the same as the F format is UD. Here W is the total width of the variable, including exponent, while D indicates the number of implied decimal places in the mantissa. The data field should contain the mantissa and the letter E followed by an integer, indicating the power of 10 to which the mantissa is to be raised. As before, any decimal actually coded overrides the format specification. The G format combines the features of the E and F formats. If an exponent is contained in the data field, then it is read using the E format, while if no exponent is contained in the data field, it is read using the F format. An SST extension to the usual set of FORTRAN format operators allows strings to be read from a file and automatically converted to value labels. The format is similar to that for floating point numbers as SW. The F and G descriptors are repeatable. That is, by placing an integer before the format description, the user can specify that the format description is to be repeated. For instances RFWD. By including a character string enclosed by apostrophes, the user can output text using the write statement. Apostrophe editing will be accepted in the FMT subop associated with the read statement, but will be ignored on input. The / character directs SST to skip to the next line of either the input or output file. Normally, when the end of the format specification is reached, SST assumes that it is finished with data transmission for the current records and skips to a new line, before beginning input or output again. It is possible for subsequent I/O to continue reading from or writing to the same record by terminating the format specification with the / character. Neither the / or the / characters need be separated from other descriptors in the format list by commas. Normally, FORTRAN interprets blanks on input as zeros. For blanks to be ignored for the remainder of the format specification, enter the descriptor BN in the format specification list. To change the interpretation of blanks back to the default, insert BZ into the format specification list. When developers go through the FORTRAN language, they may encounter several problems in this language. Now we going to introduce what are problems they came up with. As you can see, these are some difficulties of FORTRAN. FORTRAN is a low-level language. Using FORTRAN, it is difficult to write programs and enter programs. Also, it is hard to check whether you got the right result. Let's take a look at some of the advantages in the latest FORTRAN standards, and frankly it is something to be impressed. The language 20 years ago is gone now. No more line numbers and special columns. FORTRAN has been heavily used in engineering circles for 50 years now. That gives you two advantages if you work in those circles. First off, these folks care a lot about optimization. That means FORTRAN compilers tend to have the best optimizers around. The language itself is a lot more optimizable than SLIIT languages too, thanks to its lack of aliasing. The second advantage is that FORTRAN's library support for number crunching simply cannot be beat. The best code is nearly always going to be the well-debugged code you don't have to write. If your application doesn't fall under scientific, engineering, or number crunching in general, then neither of the above will be a big deal for you, so you may be better off looking elsewhere. Now let's look at the programming principles. There are 19 principles to increase the quality of the programming languages. FORTRAN violates several principles of them. Let's see what the principles that violates are, and how FORTRAN violates those principles. 0-1. Infinity principle. What is 0-1 infinity principle? The only reasonable numbers in a programming language design are 0, 1 and infinity, a special case of the regularity principle. Interpretation of this principle is, a programming language construct should be limited to being singular, 0, or able to scale to infinitely. Now let's look at how FORTRAN violates this principle. FORTRAN has arbitrarily limits identifier names to 6 characters, and using FORTRAN can build only 3 dimensions array. So there are limitations that should remember by the programmer. Because of that, FORTRAN violates 0-1, infinity principle. Defense in depth principle. Defense in depth principle state, as if an error gets through one line of defense, then it should be caught by the next line of defense. Interpretation of this principle is, there should exist multiple checks for errors in a program such that error detection is maximized. Here are some violations of this principle by FORTRAN. In FORTRAN there is no type checking. As you can see in this example, if any error occurs while typing, it doesn't show it as an error and compiler take it as correct typing. Another 2 violations of defense in depth principle are, FORTRAN has implicit variable declaration and FORTRAN has a linear rather than hierarchical structure. Because of these features of FORTRAN, it violates defense in depth principle. Regularity principle. Regularity principle defines language rules should be applied universally without exception. Interpretation of this principle is, there should not exist any exceptions to grammar rules. When we consider about the violations of this principle, FORTRAN allowed character strings to be read into integer and real variables, and permits logarith constants to be used as parameters where integers are expected. Structured programming principle. Structured programming principle states the static structure of a program should correspond in a simple way to the dynamic structure of the program. Interpretation of this principle is the execution of a program should be easy to trace given its source code. When further considering, this principle means that it should be possible to visualize the behavior of the program easily from its written form. For an example, when the execution of one segment of code precedes another in time, the statements of the first segment should precede those of the second in the program. Similarly, the statements whose execution is repeated by a loop should be easy to identify. This is simplified if they are contiguous, indented block of text. Here are some violations of this principle by FORTRAN. Goto statements are required in FORTRAN 77 to emulate while loops. There are 3 similar-looking versions of the Goto statement. They are basic Goto, computed Goto, and assigned Goto, but their behavior is different from each other. Because of these features of FORTRAN, it violates structured programming principle. Syntactic consistency principle. Syntactic consistency principle states things which look similar should be similar, and things which look different should be different. Interpretation of this principle is, the language should have visually different constructs, to avoid confusion between similar symbols for constructs. Let's see some violations of this principle. The simple, computed, and assigned Goto statements in FORTRAN are different, but they look similar. As you can see, these 3 Goto statements look similar, but if we consider about the behaviors, they are not similar. Here are some other violations of syntactic consistency principle. Take a look at these operators. They look similar, but in FORTRAN they behaved in different ways. Because of these features of FORTRAN, it violates syntactic consistency principle. Abstraction principle. Abstraction principle states avoid requiring something to be stated more than once, factor out the recurring pattern. Interpretation of this principle is, the language should have visually different constructs, to avoid confusion between similar symbols for constructs. These are some facts in FORTRAN that violate the abstraction principle. FORTRAN does not support pointers and heap dynamic variables, so binary trees must be implemented using parallel arrays. FORTRAN does not have records, so arrays of records must be emulated using parallel arrays. The declaration of the common block structure in FORTRAN had to be repeated in each subprogram. Because of these features of FORTRAN, it violates abstraction principle. Portability principle. Portability principle states, avoid features or facilities that are dependent on a particular computer, or a small class of computers. Let's look at the violations of this principle. As you can see in the example in later versions of FORTRAN, a more conventional logical if statement was added. From this assignment we are trying to give some facts about FORTRAN, and indicate how FORTRAN violates programming principles. So we hope you get a clear idea about FORTRAN. Thank you.